So this definitely is the last lesson on integration. Okay. So well done, those of you who've hung in there. Just in case you want to do it as a worksheet, I have gone and uploaded the second integration unit test through assignments into where we normally put them. I did that this morning, so that's there. If you want to have the answers, you know, I don't mind. Just let me know, and I will give you the answers. So that's there, but you know, there's no expectation that you need to do it. I guess just those of you who are going to be doing maths at A level, maths at first, might want to just work through it, just so you could have seen, you know, the standard of questions that were in it. Okay, so I've popped that in assignments. No obligation for you to do it. If you want to have the answers, just let me know. Right. So differential equations. So 11.10. I'm going to. I think it's almost easier for me to explain this generalized. Oh, guys, can you just, if you could just mute, please, because I'm getting feedback. Thank you. I think for the purposes of explaining what's going on here, I'm just going to go to the first example in a minute. Okay, but I would like to just explain this bit at the bottom. Because we are integrating, as always, we're going to effectively get a plus C. Okay, and because of that, there are going to be numerous sort of correct answers, and so we get a generalized solution. But because the plus C could be 5 or 6 or 9 or whatever, it gives us a whole series of correct solutions, and these are called the family of solutions. Okay. When you integrate to solve a differential equation, you still need to include a constant of integration, plus C. This gives the general solution. It represents a family of solutions, and that's just a model. So what they're saying is when you go and integrate this, you get this, which factorizes to this, and therefore you get this whole family of solutions. So going back to this first bit here, okay? As I said, I think it's easier just to see it with numbers in it. So example 26, you would be given a question like this, okay, where you've got x's in it, y's in it, and dy dx in it. Now, the first step is just to basically make sure you go and get everything with y's on one side and everything with x's on the other. So taking this example here, we're going to take all our x's to the right and y's to the left. So we're choosing to multiply both sides by dx and divide both sides by tan y. Tan y being divided over there, multiplying by dx. So that gives us 1 over tan y with respect to y. 1 over tan y dy equals 1 plus x squared with respect to x dx. And then we can integrate both sides. Okay, so we introduce the integral sign. When we integrate, yes, and what is 1 over tan? That is cot. So we're going to, when we integrate cot, we get ln, the ln from our earlier work in integration. And when we integrate this, remember, because we've got, again, you know how to do this, right? Because we've almost got the differential of the denominator and the numerator, we have to account for the 2, so that gives us the half. So hopefully you're okay going from that line to that line from what we've done so far. Now, at that point, because we're integrating, we introduce the constant, plus c. But this, of course, can just be thought of as being ln k, another constant. Whatever number c is, okay, it's got an equivalent ln. So we replace the plus c with a plus ln k. And now, because everything's being ln'd, we can then just use our knowledge of how logs work to go and simplify the right-hand side to make it a single ln. So obviously the power rule, we've gone and taken the half upstairs, and then the multiplication rule, just going to multiply by the k. So we've got ln stuff equaling ln stuff, so we can de-ln it, if you like, giving us that as the final answer. Right, we've removed the ln. So that's example 26. Now 27 doesn't really do anything different. apart from remind you that you may choose to go and introduce partial fractions to allow you to solve a complicated integral. But the process is still the same. We've multiplied by dx, and we've divided by y minus 2 to get all our y's on the left, all our x's on the right. We've introduced partial fractions to allow us to simplify the right-hand side, and then it's the same process. Now, on this occasion, they've given us some information to allow us to work out what c is. Okay? Just like a normal integration, if you're given a pair of values, towards the end, you can actually go and work out what the constant is. So that's the only difference here. They've given us a bit more information, so we've been able to eliminate the constant in our final answer. So that then takes you into a whole series of questions. I haven't had the opportunity, I'm afraid, to actually put these into my own fair hand, but I have made sure that I've copied and pasted the modelled solutions across with the questions. So hopefully that at least makes it easier for you rather than having to keep going backwards and forwards. So we've got 11J there, so with all the answers. And then all that then leaves us is exactly the same work, but in a real life context. It just leaves us with where we've got differential equations and we're modeling with them. So, we've often seen this towards the end of the chapter. You just have the final bits where you are taking it really from a pure subject to an applied subject. So no extra maths here, guys. We're just doing the same work, but with regard to modelled questions, so sort of real life situations. Okay, but you can see exactly the same idea. So it's exactly the same process as we've done before. So I think we have an example or two. Yes, a couple of examples. Work your way through those, and then there's just a few questions just to finish off. I'm sure by the time you've done that, you're absolutely going to be absolutely sick of integration. So I haven't actually got around to putting all the mixed exercise in play. I think once you've done bits and bobs of that, if you want to do anything, I would suggest you go over and have a go at that second integration test. And as I said, if you think that's a bit daunting to actually sort of present it for me to mark, I'm more than happy for you just to say, look, can you just send me through the answers? And I'm almost just going to copy out the answers just to gain confidence that I can see what's going on. So that's it, guys. Very well done for hanging in there. I know we've overrun. I mean, we're about 3 weeks overrun, haven't we? So it was a 4 week half term, I think, but then we had the extra week of stuff. So I think in normal circumstances we would have had to just done a few sessions over the Easter holiday. I think in hindsight, perhaps we needed a bit earlier on. But there you go. We are where we are. It's not the end of the world given what's happened. So my best wishes to you all. All right. Take care. As always, any queries, do let me know, and I will do my best to get back to you with a video. So that's it, folks.
Thank you.
Okay, cheers,
Thank
guys.
you.
Cheers, Callan. Cheers, Dom. Cheers, Becky.
Thank you very much.
Bye, guys.
Bye.